Okay, welcome to the physical properties and chemical properties notes review. I'm going to start by identifying physical properties, which are typically easier things to identify by matter, just simply by observing it and not changing it. That's really the thing. You just look at something, identify physical properties of something. Color, texture, very simple ones just at first glance. And a couple other ones we're going to hit on. Viscosity is a very good one to know the physical property. Tendency of a liquid to keep from flowing. That's really the thing. It's the tendency of a liquid to keep from flowing means that it doesn't want to flow. So things that have a high viscosity are slower moving. Honey is a good example. Motor oil has a high viscosity. Corn syrup has a high viscosity. Things with low viscosity are what you typically think of more as a liquid, right? But like water or soda, so forth. But honey is a liquid by definition. Let's move on. Conductivity, material's ability to allow heat or energy to flow. Right? Metals have high conductivity. Wood has a low conductivity, so it's therefore called an insulator. Plastic and rubber are also insulators, things that you're very aware of. Usually what's on the handle of your pots and pans, insulators, because the idea is you want to restrict or not allow heat to flow to the handle of the pot, simply because you get burned. Another physical property, is something malleable, is it not malleable? Malleability is really the ability of something to be hammered without shattering. But really the key is without shattering. You can hammer anything, but if it will bend, then it's what's called malleable. If it will not bend, then in fact it's like brittle and breaks, then it's not malleable. Glass is not malleable in the solid state. Guy over here to the left is making a sword, and blacksmiths know all about malleability when they're forging swords and knives and so forth. Some other physical properties that are pretty easy to identify, typically the hardness of the material, diamond being the hardest of all materials, talc or chalk being not a very hard material. It's the opposite on the Mohs scale of hardness, if you remember from the 6th grade, with the rocks and minerals unit. Melting boiling point, another thing, physical property. Everything has its own melting and boiling point. Water is what we normally think of. It's just the easiest thing that we commonly use, that we see melting and we see boiling. So easiest to use those kind of visuals. Solubility is the ability to dissolve in another substance. Kool-Aid obviously has a high solubility. Sand does not have a high solubility. It will start to dissolve. It takes a very, very long time and a lot of mixing. Sugar and water are also very soluble. Density is one of the more useful of the physical properties. It's useful in identifying purity of a substance. For instance, how pure gold is, or is it 24 karat gold versus 14 karat gold. And that's dependent upon the density of the gold or the metal. It's also used to identify things such as diamonds versus fake diamonds, and gold versus fake gold. They all have different densities, and if you know this, then you'll be a clever jeweler and you'll not buy something that's not worth anything. Density is defined as mass per unit volume of a material. What does that really mean? It's like basically says to identify the density of something, you need to know the mass of it and divide it by the volume of it. If you remember from the What's the Matter notes, we discussed that anything that's matter has mass and volume, so anything that is matter has a density. Density of pure water is 1 gram per milliliter, and we use this measurement as kind of a standard. Anything less than 1 will float. Like the rubber duckies down here, the rubber duckies float because they're mostly filled with air, which has a very low density. This air does have mass, it does take up volume, but has very low mass. And because it has low mass, it's therefore very low density. Definitely less than 1. I'm sorry. Here. And it'll float. The anchor over here definitely has a density greater than 1, and it sinks. Everybody mistakenly thinks that the anchor sinks because it's heavy, but in fact, the boat that the anchor normally sits on is much, much heavier than the anchor, but because of the small size of the anchor and the relative high mass of it, divided by the small volume of it, that's what makes it sink. Boats are big, and they're also filled with water, and they also displace water based on their shape, which is a whole other story. But it also holds lots of air, and therefore has an overall cubically low density. A little practice calculation there, dude. Used to identify materials. Let's see. Let's just keep going. The physical changes, which, if you'll remember back to the phase changes are physical changes. Is how something appears, looks different. Again, we use ice and water. That's just always the one we know about. Ice in its solid form looks very different physically than water in its liquid form, but then water in its steam form or vapor form looks very different too. Kind of looks like smoke or something. It's really basically is. If you can change something physically, but as long as it's still the same material, then it can be changed back. This water can be cooled down and turned back into ice, and then this ice here that's melted can be cooled down and froze back to the ice, right? So inversely, I could heat this ice cube up and it'll turn into the vapor, but it's still the same stuff. Chemical properties are the ability to produce a change in the composition of the matter. It sounds like a difficult definition, but really what it means is can something change chemically and turn into new things? That's really what it means. You can test these things, but unfortunately, when you test their chemical properties, you alter the composition or the original identity of the object. Flammability, for instance, is a chemical property. Some things are flammable, some things are more flammable than others. Most things are flammable. It just depends on how much energy it requires. Gasoline, fingernail polish, wood, these things all have high flammability. They will easily catch on fire and easily burn. A human body is not very flammable. It will burn, but it takes a lot of energy to do so. So we rate that as a chemical property as one is more flammable than the other. Reactivity is the other major chemical property. There are other chemical properties, but these are the two major ones that we're going to talk about. Some things will just combine chemically with other substances more easily than others. Baking soda and vinegar obviously have a high reactivity because that's because their acid-base reaction kind of neutralize each other. But some metals like sodium, potassium, cesium, rubidium, these are all alkali metals. Lithium, these things are very reactive in water. If you remember the video I showed from in class with the guy blowing up the bathtub, those are very reactive metals. water, of course. Oxygen is very reactive. We breathe it in every day, but it's very reactive with metals, in particular iron or steel. It makes things rust. And it'll react very quickly if you get something wet, or even if you leave it out someplace where water vapor will condense onto it. Chemical change occurs, it's a little bit different than physical change. Remember back to physical change, you have the water and the ice turning from one thing, from ice to water and water back to ice, and it's chemically the same exact thing. So it just changes shape physically. It changes, so it looks different. That's just the easiest way to think about it. Chemical changes occur when things react and a new substance is formed. Typically characterized by a non-reversible switch. So, three common types of evidence are changing color, you have things rusting. This is a penny that's patinaing, and patina is what copper does. It does not rust. It oxidizes. It's a reaction with oxygen and water, and it actually makes copper turn green. That's why the Statue of Liberty is green. It used to be copper, shiny. Production of gas is another example of chemical change. Bubbles, really. When you look for bubbles, bubbles is the presence of gas. So carbonation of soda, right? It's carbon dioxide inside of the drink, and that's presence that there's evidence that there's gas in it. So anytime you see something bubbling, it's production of gas. Last thing is formation of precipitate, which is a solid from a liquid. That's how cottage cheese is formed from milk. It's basically a bacteria that's introduced to milk at a certain time, a certain type of bacteria. And as the bacteria eat the milk, they chemically convert it to a solid. Kind of gross to think that the cottage cheese is formed from bacteria, but in fact all cheeses are created that way. So just a quick review of chemical and physical changes. If it chemically changes, it changes into new things. If I took a tissue like a Kleenex and I caught it on fire, which has its flammability, it would turn into ash and smoke. I would find this very flammable, it will burn quickly, and it will convert to ash and smoke, light energy, heat energy. But these things are new substances, and these are non-reversible. I can never gather the smoke and the ash and remake it into tissue again. It's forever changed. A physical change, on the other hand, the composition of the matter stays the same. So what does that really mean? It just means like the water to the ice and so forth. That's still H2O. It's just a different form, different phase. Another example is if you rip the tissue in half, it's still tissue. It's just two pieces of tissue. It's still chemically the same. If you crumple it into a ball and then uncrumple it, it's still tissue. So that's a physical change. It just looks different. That's really what you need to know. So this concludes the chemical and physical change and properties review, and I will see you in class.